Right. Now we are discussing the what is the constraint satisfaction problem in artificial intelligence. What is the constraint satisfaction problem in artificial intelligence? Now, first we are discussing the constraint satisfaction problem (CSP). That means is the CSP are the mathematical questions are defined a set of object whose state must satisfy the number of constraints or limitations. Constraint satisfaction problem are the mathematical questions defined as a set of objects whose state must satisfy the number of constraints or limitations. Constraint satisfaction problem represent the entities. So CSP represents the entities in a problem. And next, as a homogeneous collection of finite constraints over a variable, that means which is solved by the constraint satisfaction methods. That is the constraint satisfaction. And next one, what is the constraint satisfaction in artificial intelligence? Artificial intelligence constraint satisfaction is a constraint for propagation. Next one is the backtracking church, that is a local church problem structure. Define the constraint satisfaction problem. Constraint satisfaction problem represents the state. CSP represents the state with a set of variables and values, pairs, and represent the conditions. Pairs represent the condition for a solution by a set of constraints on the variables. Many important real world problem can be described as the constraint satisfaction problems. What are the three main elements of any constraint satisfaction problem? Any three important constraint satisfaction problems. Here is the constraint satisfaction problem is a problem that required it is a solution with some limitations some limitation or conditions. This is also known as the constraints. That means is a CSP is a problem. Constraint satisfaction problem is there is one of the problem in artificial intelligence that requires it is a solution to be within the some limitations, condition, and also constraint consisting of finite variable set, a domain set, and a finite constraint set. And next one, constraint satisfaction problem in artificial intelligence is a constraint satisfaction is a technique where the problem is solved, and it is value satisfied. Certain constraints, that means the certain constraints are rules of the problem. That means such type of the techniques leads to the deeper understanding of the problem structure as well as its complexity. Understanding of the problem structure as well as its complexity. Constraint satisfaction depends on the three components. Constraint satisfaction mainly depending on the three components. What are the names? First one is X. That means it is a set of variable. That means a set of variable. D means it is a set of domain. It is a set of domain where the variable reside. There is a specific domain for each variable. Next one, C. It is a set of constraint. It is the set of constraint which are followed by the set of variables. These are three main components important in the constraint satisfaction problem. In artificial intelligence, what are their names? X, D, and C. X is it is a set of variable. D is a set of domain where the variable reside. Next one, C. That means it is a set of constraint. C means is the set of constraint which are followed by the set of variables. And next one, in constant satisfaction, domains are the space where the variable is the reside, where the variable is read from the problem specific constraints. What are the problem specific constraint? These are the main elements of the constant satisfaction techniques. These are the main elements of the constant satisfaction techniques. That means the constant value consists of the pairs, consists of the pair of, that means what is pairs? That is the scope and real. Scope and real. That means scope is a tuple of a variable which is a participant in the constraint, and real is the relation which includes a list of values which is the variable can be take satisfy the constraint of the problem. The constraint value consists of the pairs of scope and real. That means the scope is the tuple of a variable which participates in the constraint is of real. That means is that relation which include a list of values which is the variable can take the satisfy the constraint of the problem. How to solve the constraint satisfaction problem? The requirement of this to solve the constraint satisfaction problem, a state space and the notation of the solution. And the next one is the first one is a state space, and next one is a notation of the solution. Here the in a state space is defined by the assigning the values. A state in a state space is defined by the assigning the values to some r all variable such as is the all variables. Next one. What are the types of the domain in constant satisfaction problem? Is the type of the domains in constant satisfaction problem. Here there are the following. There are the two types of the domain which are used by the variables. There are two types of the domain which are used by the variables. Here the descriptive domain. First one is the descriptive domain. That means it is an infinite domain which can have the one state for multiple variables. One state can be one state for multiple variable. For example, a start state can be allocated the infinite times for each variable. A start state can be allocated the infinite times for each variables. And second one is the finite domain. Second one is the finite domain. It is a finite domain which can have the continuous states describing the one domain for one specific variable. It is also called as the continuous domain. It is also called as the continuous domain. Some special type of this solution algorithm are used to solve the type of the constraints. Some special type of the solution algorithms are used to solve the some type of the constraints. That is what are them? Next one first, linear constraints. This type of the constraints are commonly used in the linear programming. This type of the constraint are commonly used in the linear programming, where each variable containing an integer, where each variable containing an integer value exists in linear form only. Next one, non-linear constraint. This type of the constraint are used in non-linear programming, where each variable, that means is an integer value, exists in non-linear form. Exists in non-linear form. Next, a special constraint which work in the real world is known as a preference constraint. It is known as the preference constraint. Next, what is the CSP problem in artificial intelligence? Constraint satisfaction problem include those problem which contain some constraints, which contains some constraint while solving the problem. Constraint solving the problem. Which next one is the constraint satisfaction including the some of the including the problem, that means the graph coloring, including the graph coloring. That means is the problem where the constraint is that no adjacent sides can have the same color. The problem where the constraint that no adjacent side can have the same color. That is the graph coloring. That is a graph coloring. Now here they say in this diagram, graph coloring algorithm. So here in this problem, here the 1, 2, 3, 4, 5 is the constraint. The problem where the constraint is that no adjacent side can have the same color. The same color. That is the graph coloring problem. Now, constraint propagation is a special type of the inference which helps the reducing the legal number of values variables. Constraint propagation is a special type of the inference which helps in reducing the legal number of values for the variables. The idea behind the constraint propagation as a local consistency. That means the idea behind is the constraint propagation is a local consistency. In local consistency, variables are treated as a node. In local consistency, variables are treated as a nodes, and each binary constraint treated as are the in the given treated are the problem. Therefore, the local constraint which are discussed, the local constraint which are discussing the node consistency is the most important. Node consistency. That means is a single variable. A single variable is said to be a node consistency. Single variable is said to be a node consistency if all the variables in the variables of the variables domain satisfy the in-array constraint on the variables. Next one is the arc consistency. There are a variable is the arc constant of every value in its domain satisfy the binary constraint of the variables. Next one, path consistency. That means is when the evaluation of a set of two variables, when the evaluation of a set of two variables with respect to a third variable can be extended over the another variables, satisfying the all three binary constraint. It is a similar is the arc consistency. Next, K consistency. This type of consistency is used to define the notation of the form of the algorithms. This is the local consistency. Local consistency is the constraint propagations. Is the local consistency is the propagations. The solving the constraint satisfaction problem. The requirement to solve the constraint satisfaction problem, a state space, the notation of the solution. A state in the state is defined assigning the values to some or all variables. So assigning the values to some all the variables. A state in the state is defined by assigning the values to some or all the variables, such as to some all the variables such as is a x1 is equal to v1, x2 is equal to v2, and so on. This is the a state in the state is defined by the assigning the values. How to assigning the values in the state? So here the x1 is equal to v1 and x2 is equal to v1, v2, and so on. Next one. An assignment of the values to a variable can be done in the three ways. An assignment of the values to a variable can be done in the three ways. First one, consistent or legal assessment, legal assignment. First one is the consistency or legal assignment. That means is an assignment which does not violate any constraint or rule is called consistent or legal assignment. Complete assignment, an assignment where every variable is assigned with a value and the solution of the constraint satisfaction problem. That means that remains the constant, such as the assignment is known as a complete assignment. That is the complete assignment. Next one is partial assignment. These are partial assignment. An assignment which is assigned the value to some of the variables. Assign the value to some of the variables. Only such type of the assignment are called the partial assignment. This is the state in the state space defined in the by assigning the values to some of the all variable or all variables such as the x1 is equal to v1, x2 is equal to v2, and so on. In this, assignment values to variable can be done in three ways: consistent legal assignment, complete assignment, partial assignment. This is the three types of the assigning the values to some or all variables. Some are all the variables. This is this is the constraint satisfaction problem. This is the constraint satisfaction of the problem. So the mainly defined in this problem, we define the constraint propagation, backtracking, search, local search, problem structure. This is the main important in the constraint satisfaction problem. Other than constraint propagation, backtracking, search, and local search, problem structure. And next, constraint satisfaction represents the state. Constraint satisfaction represents the state, a set of variable. And next one, set of variable are value pairs. Variable are value pairs. And represent the conditions. And represent the condition for a solution by a set of constraints on the variables. So now the many important in the constraint satisfaction. Real world problem can be described in the real world problem can be described in the constraint satisfaction problem. This is artificial in the constraint satisfaction problem.